Welcome everyone to one of the afternoon sessions of the Global Azure Summit Bootcamp, however it is called in Lüdinghausen. My name is Wolfgang. I'm from Austria, and I'm very happy that I can join your event and present something about the continuous integration for BI developers. I'm working as a data consultant in Austria. I'm working with data, I'm transforming data, I'm integrating data, I'm preparing data models, and I'm building data warehouses since more than a decade together with our customers. And what I would like to go through today is a little bit of a story, how somebody could feel when he or she gets into a new team, a new BI team, and what are the challenges and maybe some interesting topics, how the team itself can get better and can get into a more better round process around the BI development. Yeah, imagine we are new to a team. It's our first day, and we are getting the introduction about the overall project setting. We are getting part of a BI development team, and they already built a solution. Classical on-premises data warehouse, having some data sources on the left. We have some integration services packages to transform, to load the data into the staging area, ODS, and data warehouse. And we have a semantic model using analysis services, Tabular, and Power BI as the front-end tool. Looks nice. And then they talked about the development approach they are currently using. And what they do is, well, they use Management Studio to work with the data, to develop the database, which is nice, but it's a little bit tricky if you hear the story, how they work and how they really develop. They also use Visual Studio to create integration services packages, to create the tabular model. And what they do is they store those projects on the hard drives. They store those projects on the hard drives of the different members of the team. So we get more versions of that development. We will see it on one of the next slides, those underscore final, really final, and some date directories. And well, they do a great job, but it's not that easy because they also work with Management Studio directly connected to the databases. And they have no development instance. They have only that one specific production environment, which doesn't really get funny if there's a problem. And with Power BI, yeah, they are using Power BI Desktop to build the reports and to publish that report files manually to the Power BI service. And yeah, we had a discussion the first day, and they said that's how we roll. And how they roll, yeah, I mentioned it. They are working directly in the database. They are changing views directly in the database. Sometimes they are creating some backups, some copies, including a date or not, or Ben, Hugo, or to delete or whatever. And they are changing stored procedures like directly, and they are using stored procedures for their data transformation, which is a good way. But if there is a problem in one of those updates and they are publishing that version of the database or storing the database, the version in the database, well, it can be a problem. What they also do, it's manual work. They are building the integration services packages, test them, and they test them in production, which is not the best way. And they have to deploy it manually. The same with the tabular model. They deploy it manually. They change the model directly at the open, at the pumping heart. And what they also have I already talked about that. Some copies of the development at the local hard drive, which can be nice, which can have some sort of information like the date when they introduced that version, or it was milestone 2 hotfix 1. And there are some directories like copy 1, 2, and 3. So what is it really? What is the real working version? What is the current version they are working? And well, in that case, we could assume it's the current SSIS directory. But that could be the current version on the notebook of team member 1 or at the notebook of team member 2. So many, many different ways of how to screw up the overall process. And then during the day, when they do some development, well, there's that thing called telephone. And some team members or the consumers of the data warehouse, they just phone the team and say, hey, something's not working. There's a problem. My numbers are not correct. That measure doesn't work. I don't know what else. So many, many different ways of errors that can occur. And yeah, during the pandemic, the phone, well, it changed to the mobile phone, it changed to the home office, it changed to the Teams client. So we were under fire, let's call it that way. And some days, well, they just ended or began with hello, my friend, like that, as in the picture. And we had some team discussions, and then we said, okay, dear team members, need to change something, because it's not the best, not the ideal way of dealing with a data warehouse, a production data warehouse. People are using it, people are trying to use it on some days. And well, I suggested we need to change something, and my boss said, well, yeah, you get 1 week. And as we've only 1 hour at that session, well, I've got 1 hour to introduce another concept, maybe a better concept for a better quality, a reproducible quality of BI development. And we sat together and we built a checklist and a to-do list. What are the points we want to do? What are the points we want to solve? And first of all, I suggested let's create a development environment where we can work, where we can develop all that stuff, and we don't have to get the production database into danger. So we have to find a way of clone the production database and develop in production, or in development, sorry, and deploy to production. The next step, we should build and focus on one common development structure. So one storage, one truth. Not every team member's notebook is the storage, but the other colleague says it's my notebook that is the storage. So we have to think about a common storage, one truth, and maybe some history, who did what. And also automation. There were many manual things involved, manual steps involved. So what I could imagine and what we are planning to build now is some automation to push our development to the dev environment. Whenever we are done, we can push it to the production environment. Whenever we want, we can create another environment like an integration testing environment, whatever. And it's built on the same and exactly the same structure and using exactly the same integration services packages and using exactly the same analysis services model. And also the traceability, because sometimes, well, you were the first person that answered the phone, but not the person that did the change in the store procedure that broke the data warehouse load. So who changed what and when? The why, well, that is the next step, that we have some sort of work items we can check to and link to. But now it's the thing of getting some sort of traceability in there. And for the dev environment, well, we thought of changing the way how to develop. Going away from the management studio, directly opening the stored procedure and changing the way or the logic in there. to using SQL Server data tools, database projects. So it's a completely different way of not directly working on the database structure to focus on the result. So what is the final state of the object we want to create? And that's the create table statement, for example, for a table. And it's not the alter table statements we are performing one after the other. So that's the final state of the object. So it's a declarative database development. And how does that work? Let's switch to the demo. If we have any questions, or if you have any questions, just put them into the chat. Did they use the on-prem gateway for Power BI? Yes, they did use the gateway. I've just skipped it out of that way because we could have done some automation around that, but the automation gateway or the on-premises data gateway was in use at that project. So for the database project, within Visual Studio or Azure Data Studio, we can create a new project, and we can create a new project which is of the type of SQL Server database project. And for those of you that do not know the database project's development, so I'm gonna create that one. It's the Lüdinghausen DB. And I create that, or at least I try to create that one. Yeah, Visual Studio likes me. And what we create here and start with, it's an empty project in here. And what we can add to that one is a new definition, a new item, a new table, for example. So what I would like to add is the attendee table. We are using, or we can use the graphical designer. So attendee ID and first, oh my God, name. And the last name is required, or the SQL editor. And when we are done, what we now have to do, because we are designing and declaring the final state of our database project in Visual Studio, what we are required to do afterwards is we need to publish that one. We need to publish the content of that database project, and we need to publish that one to a SQL Server. Prepare the SQL Server, and there is no Lüdinghausen database. So let's go over here, hit write publish, and what is done now, we need to specify the target connection. So I'm gonna go here and change it to Lüdinghausen, the database, and we can generate the script or we hit the publish button. For the demo, I'm going to hit the publish button, and in the background there's some magic involved, because what Visual Studio and the tools in the background are performing, they are creating the database if it doesn't exist, and they are comparing the state of the target database compared to our Visual Studio project. And in one final go, we created, or Visual Studio created, a new database containing one table for this sample. What we can do now is we can add let's add the email address here. Makes sense, but just to add another column. And now in the database, we have only 3 columns. In the project itself, we have 4 columns. And what we can do now is, again, take that one and we do this generate script, because now we can have a look at the update script. The Visual Studio it creates the publish preview. What it does is it compares the target and our Visual Studio project. And what we get now is some blah, blah, blah magic. And we've got the auto database script here. So we could fire that one up and send it to the database, or we could just generate and publish that one again. So it's very easy to define your database structure in Visual Studio. And now it's very easy to create a dev environment using the same source code and a production environment, because during the publish process, every time the Visual Studio project state is compared to the database state. So we have some sort of comparison, not only sort of, we have a comparison between the state of the environment or the development and the target database. And now what is still missing, well, I forgot one, because the project itself, it was already implemented. So we had databases, and we had some sort of staging databases and data warehousing databases. What you can do and start with is, let's start here with a new project. We create a new SQL Server project, and that one is the staging DB. And that one is really, really nice because you can import the database structure from an existing database. So we take the production staging database, select the connection, and we take the wide world importers here, connect to that one. And Visual Studio now allows us to import all the structural objects, beginning with schemas, file groups, logins, tables, views, procedures, and everything that is in the database. So we can start with one starting point, and that starting point is the current version of the truth, which is the only existing database. And within seconds, we get a list of tables and package type table, for example. We get all the definition out of the database itself, including extended properties and so on and so forth. So really good way to start into the database development. If you are starting from the greenfield, well, it's that part, because you can start with, oh, no, sorry. You can start with the empty project and just add your table definition. The next step, well, who did what and when?
Maybe a short question, if that's okay.
Sure.
How does that perform in your experience for big database projects?
The import or the
schema compare?
The schema compare.
Yeah.
Sometimes you need some time to wait for the schema compare.
Okay.
Yeah. What I made the experience in some of our customers' projects, we have, I don't know, 6-7 databases that are included in the overall database solution. And there it can take some time, because you can have references to other databases. And those references need to be validated. And that validation can take some time, because what Visual Studio does is it somehow compiles your database. So if we hit the build, we get a list of output commands in here, and it does a structural change, checks if there are non-functional references and everything and so on.
Yes.
And that let's say not the best performance was achieved with having multiple databases which are quite complex.
Yeah, I found that when you're having several hundred database objects, at some point performance tends to break down.
Yeah, I haven't found out if it's 200 or 500, but that's correct. Yeah, okay. If it's getting too much, and there's one thing I haven't shown in the demo, you can do some refactoring.
Yeah.
So
it's not me doing it wrongly, but it's an experience that you also share.
Yes. And
okay, thanks.
I haven't worked with the Azure Data Studio database projects, to test them out how they perform. So maybe they are better implemented because they can be used interchangeably. You create it in Visual Studio, open it in Data Studio, and so on, and vice versa.
I think they use the same schema compare binary that comes with SQL Server.
Okay, yeah, then
so I would expect it to perform much better.
Yeah, then it's...
what I tended to do with one customer, we had this problem that the schema compare took like over an hour.
Oh, okay.
Because we had actually thousands of tables and views and stored procedures.
Yeah.
And we switched to the Redgate tools then because they were just much faster.
Yeah, that's right. There are other tools that can be used for that. Those are we want them for free. Because my boss said, hey, I don't want to invest money for your POC. And even afterwards, if it works. So those are
totally fine.
Yeah.
Those are always the starting point because they're very well, but they have their limitations.
Yeah, sure, they have. And what I've seen with the refactoring approach, that works well. But if you have many refactoring steps in there, it gets slow. It gets slow whenever you open the project and so on. So that was one of my experiences in there.
Yeah, okay, thanks. Sorry for the interruption.
No problem. If there are any other questions, just unmute or put them into the chat. And the next thing was the common development structure, source control. No folder-based version control or zip file-based version control. For the developers, version control, it's definitely yes, and there's no question. But what I've seen in our consultant gigs in the BI environment and in the BI field, what? Source control? Because why? I don't need that. So it's some sort of evangelism to really convince the people, hey, source control is important. And the other aspect, I already told you, it shouldn't cost too much because we want to save money. We want, or my boss said, we don't want to spend money on source control because nobody needs it. And what I found and what we did, we found that Azure DevOps is a very good solution. And the best thing is they have a basic plan, which is free for 5 users. And those basic plan includes everything we needed. So we had the option of storing and creating Azure repos. That is the part where the source control comes in. And for the next part of the demo, the Azure pipelines are included. So Azure pipelines for the automation, for the automatic deployment, and Azure repos for storing the version of our development. So good start. And how does Azure DevOps look like? Well, it's web-based, it's cloud-based, it's hosted in the Azure cloud. And what we can do here is we can create new projects like a Lüdinghausen project. And we can create that project, and the project is the umbrella around our development stuff. Within that project, we can start creating work items like our task we want to achieve, our planning and everything and so on. Those are the boards and the work items, everything around that. For the version control, we have repos. So repository is here available, and we can create multiple repository in there, and we can clone that one and configure and link Visual Studio or another tool, a local tool, to the remote repository, that one that is created here. What I've experienced, and especially with the database projects and Visual Studio projects, have a look and don't forget to initialize your branch with a gitignore file. And you can select the gitignore file for Visual Studio, which is definitely a plus because it excludes some file types that shouldn't go into version control. And so you don't have that sort of sound that is not really the development artifacts, but user settings, and so on and so forth. So git ignore is the thing you want to do. And what you can do afterwards, you can clone that remote repository and clone it into Visual Studio, clone it into Visual Studio Code or whatever. And the next step is in the Visual Studio side. You have the Team Explorer, and we've got the local version linked to the remote repository. And whenever you do a change in your project, like changing something here, log level, and adding the log status in there, you get a short mark here. That one is changed, and you can go over here, go to the changes, and enter. That's really important because we want to achieve reproducibility. Enter a commit message. Change in log table. That one took us some month to convince all our colleagues. And whenever done, you can commit that one and push it to the remote repository. So how does the remote repository look like? Let's go to that one, and we can have a look at the history. So what are the changes and what are the comments that were put in there, revert? What are the changes that are done in the SQL project, or what are the changes in the SQL code? So reproducibility. Everyone else knows what has been done. So really easy to put it into a central source, and everyone else that is working on the project uses the same version of the truth. So take that one, put it into the changes, commit it to the remote repository, put in a comment, and afterwards we can see what you have done yesterday or the day before and what object you change, which makes, well, debugging, which makes tracing for some errors much easier. So that is very a handy feature. If you haven't implemented version control in your projects and BI projects, so I need to convince some of my colleagues every new project again. It's some sort of annoying word, but it helps you and it saves your soul. The next stop, well, automation. What we really need to do and wanted to do is to automate everything. So we've got the database projects. We've put it into source control. And we are now able to create a new dev environment. We are able to publish to the production environment, and Visual Studio does the data schema compare. And the next stop, well, it's automation. So what we had a look at is the automatic way of building the database projects to check if there are some incorrect references, invalid views, references to columns that do not exist, and so on and so forth. And afterwards, if everything works well, we want to publish the database project to an environment. And how can we achieve that? I've already mentioned the build pipelines of Azure DevOps, and they are the technology we used for that one. So continuous integration, the CI part of that story. In the software engineering for the developers, CI, it's clear, but for the BI developers and the team, we had to go through and we had to talk about the practice of merging everyone's work into one central mainline, and to restart your work the next day with the same version that everybody else uses. So it's the central version, it's version control, it's the continuous integration of your local work into the central work. So what the pipeline will do, and what the pipeline does, it picks up the code changes from every developer, because every developer is forced to store it in the version control, in the repository. into the single repository and validate the source. So that is the first step of our pipeline we implemented. And whenever those changes are validated, there's the next step. It's the continuous delivery, the continuous deployment process, the CD. So the pipeline, the next step, it picks up where CI ends. So the validated the build database project, and it delivers the artifacts into environments. And I've written here artifacts because database projects are one part of the story. We have integration services projects, we have analysis services projects, and we have Power BI reports that should be automatically pushed to the environments. And it should be automated. No manual work or minimum manual work should be included. And the concept, well, Azure DevOps, it's already in the name DevOps. So it's when I started working as a consultant and a software engineer, it was the complete separation of development and operations team. So whenever we've started and finished some tasks and some versions of the software, well, we put it into operation by handing it over to the operations team. And we got somehow a notice if it didn't work when the operations team gave us the message. With the DevOps, well, it's a continuous loop of planning, delivery, or planning, develop, delivery, and operation. So it's a continuous loop, and the people are not separated. So developers and database developers, we are also in the responsibility of doing and monitoring the operation of our applications. So it's a completely different way. And automation is really, really needed in that part. And somebody has to do the work. If it's not me or my team, somebody has to do the work. And the work in Azure DevOps is done by agents. And there are two different parts and two different flavors of the agents. We have those self-hosted agents. Those self-hosted agents are agents that are provided by Microsoft. And they are provided in, the Microsoft agents. The Microsoft hosted agents are provided by Microsoft. And they are provided in different flavors. Windows-based, Linux-based, macOS-based. And in our pipeline definition, which we will see in a moment, we define what is the image, what is the kind of flavor we need for the hosting agent. In the virtual plan, in the basic plan of Visual Studio of the Azure DevOps, there are some certain build or agent minutes included. So we can spend, I don't know if it's 5,000 minutes, 500 minutes. I have to look it up. There are some minutes included and they are free. For the other way, you can use your own server, your own machines as self-hosted agents. It's very easy to install a self-hosted agent. It's in the Azure DevOps portal, in the agents pools, and it's a download, and afterwards it's some PowerShell to register the agent within your environment. And that agent does the magic and does the work. So if we go here, project settings and agent pools, we've got the Azure pipelines. Those are the Microsoft hosted ones. And we've got the default pool. I haven't named it correctly. And I've got one agent, and that agent is registered on my machine that runs the SQL Server, that contains the tabular instance, and so on and so forth. So it's really easy to create and register a new self-hosted agent. The pipeline is very easy to create. Let's go over here and go to the pipelines. And I've already created some pipelines, but I want to start with a new pipeline. the first step is we have to select the source code repository. Where is the version or the source code we want to build? So Azure Git repository, that one is my repository. And now we can choose what type of project we want to build. In my example, I'm going to start with a starter pipeline. So there are many different templates for starting and building pipelines. But in my case, it's just a starter pipeline to show you the concept, what is working behind. As you can see here, that pipeline, it uses a Microsoft hosted agent, and that one is using the Linux flavor, so Ubuntu latest. And then we've got steps. Steps are the steps that the pipeline needs to follow. And there are only 2 steps here included, which is an echo and another echo step. And you can add display names and everything else. And the trigger part, so line 6 and 7, that one is really interesting because that brings the continuous integration approach in it. The trigger defines what are the events when that pipeline starts or needs to be started. And the trigger master means if there is a change in my main repository, after the check-in, after the commit, the pipeline starts to run. So that one is the continuous integration approach. And now just hit save and run. So that one doesn't really do a magic, it just outputs, but I want to show you the steps and the process behind. The job itself is now waiting for a new agent. Acquiring an agent from the cloud. This can take some seconds, some minutes, but now we've got an agent. We've got an Ubuntu agent. And what we get here is, well, step 1, run a 1-line script and run a second script. So we've got some output in there and so on. So that is the minimum version of a pipeline. But what I've prepared, well, it's the TV cooking show. I've already prepared something for you. I've prepared a pipeline for our project. And that pipeline, actually, in that second, it's not enabled for the continuous integration. So that one is commented out. What I use is my self-hosted agent. It's using the agent pool, which is called default. And today it contains only 1 agent. And then I've got several steps in there. So the steps and different tasks that are required. The first one is I need to build, or not I, the pipeline needs to build the database project. So check that one solution file and build all the database projects that are in there. I've got 2 database projects, one for the staging and one for the data warehousing. Next part is we've also put the integration services projects into source control. And that one, or that part of the story, the integration services projects, they need to be built too. But that one is different because that part is using a task which is called SSIS build. The other one is using Visual Studio build. And there is a huge list of tasks included in Azure DevOps. And there are some tasks that can be installed and can be acquired from a marketplace. And that one was one example, the SSIS tasks. So these tasks can be configured within your Azure DevOps environment, and you can use them afterwards. If you are not that familiar with the syntax of your pipeline definition, it's called YAML, yet another markup language. But you can also go over here, settings, and define everything. So put the project path in there, the configuration, and where to put the output. Next step is copy the files and the database files to the artifact staging directory, the ISPEC file, so the output of the integration services. And we need to think about the analysis services project. So we've got the model.bim file, and we also take that model.bim and just copy that one to the staging directory. That is the first part. And now we need to deploy the database projects with our, after the build process, put into a file which is called .decpack. And for that part, we used the SQL Server database deployment task. That one needs the SQL decpack file, what decpack file we want to publish, and then we have to put in the target database server where the database project should be deployed. What you can see here, we are using variables in here. So you can use variables on different parts. You define those variables on one part. You can change the variable for every run of your pipeline, and you can deploy to one server or the other, or one instance or the other. And also you can store some secrets in there. We have to deploy the staging database, the data warehousing database, and integration services projects. So another custom task is needed here. It's the SSIS deploy task, which takes the ISPAC file and deploys it to an integration services catalog into that destination path. And that's it for the story. For the tabular editor, we had some sort of thing. There was no real, from my side, no real working task that I could use. But tabular editor, for those of you that do not know tabular editor and are working with analysis services, tabular models, have a look at tabular model. Quit my session, go to tabulareditor.com, download that one and have a look. That's the tool for tabular development. And tabular editor has a command line interface. And what we can do is we can download a version of tabular editor on our build agent, extract that one, and use tabular editor command line to deploy the new version. And that's it. So we've got the build process in here, build the database project, build integration services project, deploy the database projects to the server, and deploy the integration services project. And last but not least, download tabular editor and deploy the version. So variables are here, and there are some parts that are hidden, like the database passwords and so on and so forth. But for example, the database name or the instance name can be changed for every run. And what I would like to do now is I would like to start a new pipeline run and change some environment settings. So I want to deploy to the dev environment, and I want to deploy to the Lüdinghausen Wild West importers. Variables are set and run. What we can have a look here is A, waiting for the job to start, or B, just go to the database and that we are on the right spot. That is the dev environment, and we've got no Lüdinghausen database in there. So just to be sure. And now everything runs in the background automatically. We don't have to change anything. It's just a new version of the database project, of the integration services project, needs to be committed to the version control. And then everything is done in the background on our agent. Check out, build of the database project, build of the integration services project. And the other steps that follow are for the deployment afterwards. And that one takes about 2 minutes, and we can go further within the slides and go back and check in a few minutes. So the pipelines, yet another markup language, YAML, to define the structure and the steps within your pipeline. And it's very easy to extend the functionality of your pipelines with custom tasks, with tasks from the marketplace, and even just put a PowerShell script in there. So if there is no task involved, many of those services, they have PowerShell APIs or PowerShell commandlets, and they can be used. Start small, yeah, and get bigger. Start with the beginner pipeline. Have a look at the different tasks that are available. Use the configuration dialog on the right side, and if you are more familiar, you can edit the YAML file in there. For integration services, analysis services, reporting services, there are some commandlets and tasks for the Azure DevOps pipeline, and some require a little bit more of work, but there's a very good blog post at tabulaeditor.com which describes the way how to download and even the source code of your YAML part of the DevOps. For the reporting services, we have PowerShell commandlets that can be included. For the Power BI automation, that is the part I haven't shown you in that one demo. The Power BI automation, everything around Power BI automation, it's based on the Power BI REST API. And there are APIs, yeah, Nicolas, I'm coming to that part, and there is something fancy in there. The Power BI automation, everything around that is based on the Power BI REST API. So there are API calls to list the workspaces, to create workspaces, to add users, to upload reports, to change connection strings, and so on. And the REST API is used in many different flavors. So there are command lines, there are PowerShell scripts that can be used, and they are calling the PowerShell, the Power BI REST API. The BI DevOps, well, that is the Azure DevOps. That is the demo I'm gonna do next. And we can use it in deployment pipelines. Oh no, sorry, deployment pipelines are in the Power BI service. And also external tools are using somehow the Power BI automation. And also Power Automate can be used to trigger a refresh, which actually calls the Power BI REST API. And there are some external tasks. The Power BI actions from Mike van der Gaag, and they can be used in your pipeline. So that one is finished. 2 minutes, and just to be sure that it worked, and it worked as it was green, we've got 2 databases deployed, including the latest version of our source code, including all the required settings. And for the Power BI deployment, in one repo, we are checking in the Power BI reports. So 3 reports are included in here, and the pipeline I've built, that one includes some steps. We are not using the self-hosted agent. We are using one from Microsoft, and we are using the Power BI actions, the custom tool I installed and got from the marketplace. And we are creating a new workspace. So it's the automation workspace that is called DevOps. And then we are adding users to that workspace. And you can select the role level, the role that should be added or assigned to that user. Next, we are uploading all the reports that are in the repository. We are using the upload report. There are other actions that can be achieved, like create workspace, we've already seen, add users, add security groups, refresh a data set, and so on. So many different actions. In that case, we are uploading the new reports, and we are now updating the data source. In my part, we are taking or replacing the old database server name with a new name, and we are updating the data source. What we could add here, for example, would be another step to refresh the data set, to, well, load new data into that data set. And that is the way how you can combine Azure DevOps, Power BI, and the automation story into your reporting infrastructure, into your BI development. What I've shown you, yeah, it's the getting smarter thing. So start small with an easy pipeline. Put the things you need, like building your database project, get the task to build the SSIS project, and then look out for the right task to deploy the database project, to deploy integration services, analysis services, and also Power BI. And what I really use and really like to use are the variables. With those variables, you get those, well, the changes that don't require to change the pipeline itself. You only change one way. And what you can also do, and what we've implemented in that one, is the database name. It's, let's start with clear. The database name, it's the base variable. And you can reference variables in other variables. So we are entering a name here, like I did with the Lüdinghausen Wild West importers. And the data warehousing database, it's always named starting with the variable name plus data warehouse afterwards. So very easy, and have a look at the variables in there. And as you can see, you have those secure values to store the database passwords and everything else that shouldn't go outside. For the Outlook, if you want to go to the next step and have different environments, my demo was built the easy way to have CI, so the continuous integration plus the continuous deployment in one pipeline. But there are also release pipelines, and the release pipelines, they are starting and using the output of a build pipeline, and you can build different environments like a development environment, user acceptance environment, and production environment. And you can even put some sort of approval in there. So whenever the development part needs to go into the user acceptance environment, you can define approval. Some person, some group of person, they need to approve that those changes can be deployed. And also for the production. And with that approach, it's very easy to just build some sort of release package and put it into UAT or put it into production. And you have reproducibility between those different environments. So that is the next step. And that was not part of our week of POC testing or 1 hour of creating a session around that topic. But that is the next thing you could imagine to build and build upon to automate it the next way. And to wrap it up, to get it to an end, what have been the goals for our, well, bringing BI development to the next level? And there was the thing of common development structure. So getting away from the operating on the production database, changing values, changing stored procedures directly. So no more folder-based development, because we are using version control. We are committing all our changes to a centralized version control. We are working and talking about the same version. So it's the single source, the single version that we are developing. What else did we change? Well, database projects. We shifted from the direct database connected development to the declarative database development, with database projects having the state of your database in the source code, and you can deploy, or Visual Studio does the magic in the background to do the schema compare and only updates the versions and the artifacts that are required to be updated. For the automation, Azure DevOps. was introduced to store the single version, the repository, to build the artifacts, and to include the automation. Because that automation was introduced with the pipelines. So all the pipeline steps, getting the source code, building the source code, deploying the versions to the different environments, and updating the tabular model, and so on and so forth. And also the automation around Power BI. So continuous integration and continuous deployment were the task or the wishes we had, and we could achieve that. And also the dev environments. They started with having one dev environment, and now, well, there are dev environments almost for every developer. So it's that kind of easy to just create a new dev environment and work on your own database and have your own dev environment. And also the traceability helped, including the part of managing the work items task in Azure DevOps to have some traceability and linkage between the actual requirement, the actual task that was done, and the source code that is, well, connected to that work item. And the number of hotline calls, the telephone calls, the team calls, and so on, well, they got less and less because we are not dealing and working on the production database. We can test, the users are able to test before we put it into production, and it's reproducible. We know what part of the database was changed, what part of the integration services package was changed, and so on and so forth. And we had green check marks, and especially the last green one was the thing that the team really wanted to solve. So it was a short overview, a more general overview about the concepts of getting continuous integration into BI projects. And I'm happy that you stayed until the end, and I'm happy if there are any questions I can answer or some discussions we can start.
Thanks for the presentation, Wolfgang. I have maybe a comment. In my experience, there's a reason why DevOps is not so popular among BI developers. And that's mostly because the tooling is not as good as it is for software developers. So yeah, in many areas, we lack the tooling. We have to search through dubious marketplace extensions, try out. There's not like a best practice to do this. And if you take this a step further and talk about test-driven development, it gets even worse because it's not so easy to test database development.
Yeah.
Yes. I did similar sessions with Gabi a few times, and I think most of the comments we got was basically the tooling is just not there for BI developers. You have to build it up like a puzzle yourself.
Yeah, you have to look for tasks in Azure DevOps. Is it the right one? Is it working? Is it working with the current version of Power BI, for example, or was it a test some years ago? And what I already also seen is some sort of lacking education in the BI or database people's area. Whenever people are studying or coming from software engineering and they have some programming at school, they know what version control is. But all my colleagues and most of the people I meet at my customers that are in BI field, version what? So they don't know what version control is.
Absolutely.
They don't know what the pros are of using version control, and I often compare it to the versioning in SharePoint lists. Yeah. To give them some sort of idea what it is, and also to put documents in SharePoint and not to send it via email. Those are the things I try to to explain to those users. And that is also a thing. And I see it in my group of colleagues and at my customers. It takes time and it takes discussions, sometimes endless discussions to only get some sort of access to a Git repo somewhere. Yeah.
Yes.
And those are the small things that really make it hard to convince people. And what I usually do is I show them the pipeline or some sort of pipeline. And well, sometimes there's a bet around beer involved if I know the people better. And I say, hey, you start to deploy a new dev environment and I start the pipeline. Who else or who is faster? So those are sometimes the things that they need to be convinced to get into that field. But it's not easy, and it's sometimes hard to convince the people that they have some sort of pros when they are only thinking about that way of developing.
Yeah, I absolutely agree with you too. I would say another difficulty is, have you ever tried to merge an integration services package?
Yes. I hated it.
Yeah.
It's pretty fun.
Thanks for reminding me.
Yeah.
It's better in those days, in our days, because they changed the order so that it's always the same integration services packages, but it's horror.
Yeah, in the beginning it was if you saved the package and you saved it again, it was a completely different order. Now they have some sort of order, but it's not easy to merge. Yeah, I agree. Yeah.
And that's really a problem also with other kind of projects.
Yeah, that goes along the lines that BI developers are missing the right tooling.
Yeah, and I think it wasn't on the strategic line for Microsoft to give BI developers the tools for doing or having source control and working in that. But yeah, we have the hard work now because we have to do it and convince it. But in small steps, it's getting better and better. But for those on-premises tools, I'm not sure if there will be better or many improvements in the next years. That will be interesting.
Yes, it has been difficult and is still difficult. Also, you have other problems as in a classic software development project. If you build an app or something like this, you normally work in one world, which is only changing in a way you as a developer allow it. So, and everything as well encapsulated and all this stuff. You have your software classes in whatever you write. In the BI system, you also have stuff you cannot influence. If this data from that source system is coming in another format or something like this, it will crash anything in your production system in a minute. And to handle that stuff is much more difficult than to say, okay, did I do everything right in my Java classes or whatever?
And there comes another thing that along with databases comes this ugly thing called data. And so while you might write any alter statement for your database that you like, if you make a column not nullable and it contains null values, your alter script will just fail. I mean, you can write alter statements as long as you want, and they can be syntactically correct and they can work on your test system and on your dev system, but in prod they might still fail.
And it's those tiny little updates or database refactoring steps that can take hours to figure out why it doesn't work. And in normal source code and programming languages, it's a change in the source code. The problem lies in the database or in the update of the database. So that is, we have to deal with completely different challenges and opportunities. Let's call them opportunities. Yeah.
Totally. But still, it's worth doing, because I think nobody sleeps well on deployment night.
Yeah. And if you have some sort of what I see, it's the version control and the history. In many cases and projects, it's just a zip file, maybe with a date or maybe with a name who changed it, but what? Yeah. So those are the small steps, and I try to convince my customers, let's start with version control. If we don't want to do some pipelines or whatever, let's start with version control. And if they don't want to move into the database projects, well, I do a right-click script database at the end of my working days and put it somewhere in a version control. It's not the best way, but I have some sort of history with that. And then I try to convince them using database projects, and license is involved. No license is involved. So there are many discussions that need to be done in order to start.
Yeah.
Have you ever, Wolfgang, dealt with Power BI data flows in Azure pipelines, getting and pushing it forward?
Not now, but we can ask Tom if he has done that part.
A colleague of mine had a project, and it was really very painful. He said the API is not really ready to do such things. So yeah.
What was the question?
Data flows, Power BI data flows, automation in Azure DevOps pipelines.
What is Azure DevOps?
You don't know Azure DevOps. Hey, you are 1 hour too late, Tom. I'm gonna invite you to that session. Azure DevOps is some sort of automation system. You don't know that. Oh my God.
Kidding.
Tom left the meeting. Oh my God. No, I haven't done the combination of data flows and Azure DevOps, but I heard that the API could have some improvements. But
so basically, maybe it will be possible in the not so distant future, because the deployment pipeline API has improved, and I assume that this also will indicate that the data flows pipeline will also improve. But currently,
let's hope.
Fingers crossed. Yeah.